This video goes over your multiple representations practice key. Feel free to scroll through to the questions that you missed and that you need to review on how to solve. For this problem, we have to write an equation for this table. So let's start by finding our slope. To find our slope, we need to find the change in y over the change in x in this table. So let's start by finding our change in y. To do that, we're going to go from one point to the next and see what we had to do to get from one to the other. So to get from 0 to 12, we had to add 12. And now we're going to do that same thing for our change in x. How do we get from negative 12 to negative 6? Well, to do that, we would add 6. Then we take our change in y value, put that on top, our change in x value, put that on the bottom, and then we simplify, which gives us our slope of 2. To find our y-intercept, it's super important to remember that your y-intercept is the value of y when x is 0. So we're going to look in our x row of the table here, and we're going to go from negative 12, negative 6, negative 4, negative 3, and then 0. And our y value when x is 0 is 24. So that's our y-intercept. Finally, all we need to do is plug these into our slope-intercept form for an equation, and we're going to write y equals 2 times x plus 24. And now we have our equation. Question 2, we're given a table again, and we're writing the equation of the line represented by the table. To find our slope, we do change in y over change in x. So to get from 1 to negative 4, I'm subtracting 5, and my change in x, I'm adding 10. So when I do change in y over change in x, I end up with negative 1/2 as my most simplified form. And then my y-intercept is the y value when x is 0, which is provided to us in this table. So I know my y-intercept's negative 4. So my equation will be y equals negative 1/2 times x minus 4. For question 3, we're writing the equation that best represents this graph. So to find our slope, we're going to find rise over run. To do this, we're going to find two perfect points on the graph. So I see one here, and I also see one here. And when we're finding rise over run, we're going to see how much vertical shift we have to do over how much horizontal shift. So to get from our first point here, I would have to go down 1, 2, 3. So my rise is negative 3 because I'm going down 3. For my run, I'm counting how many times I have to shift horizontally, so left and right. In this case, I would have to go once to the right. That's a positive shift, so that's a positive 1 for my run. Then I simplify negative 3 over 1 to negative 3, which will be our slope. To find our y-intercept on a graph, we look to see where our line crosses the y-axis. And we see that right here at this perfect point that we used. This point's ordered pair is 0, 2. And we keep in mind that when we're finding the y-intercept, it's the value of y when x is 0. So our y-intercept is positive 2, giving us the equation y equals negative 3 times x plus 2. Question 4 is also having us write an equation from a graph, so we're going to start by finding rise over run between two perfect points. Our perfect points can be found here and here, so let's see what we have to do to get from this leftmost point to the rightmost. To get from negative 4, 0, we would have to go up 2. Because that's a positive shift, that's going to be a positive 2. And then we would have to go to the right 1, 2, 3, 4. So that is a positive 4. When we simplify this down, that gives us a slope of 1/2. Now we find our y-intercept. We see that our red line here crosses the y-axis at this point, which is at 0, 2, meaning our b value or y-intercept is positive 2. Now we're ready to write our equation, which will be y equals 1/2 times x plus 2. When you're given a word problem and you're told to write an equation that represents the relationship between a variable and another variable, we're going to figure out which one is y and which one is x. So for this problem, m is our x value because monthly payments are happening over multiple times. So that's our variable x. And then t is going to be like our y. So I need to see, to figure out my slope, what number is multiplied by the number of monthly payments. This $75 is an initial payment, so we'll come back to that, but that's not getting multiplied each month. But 42 each month, that's getting multiplied. So our slope's 42. This initial payment of $75 is our y-intercept. It's that one-time fee. It's our constant. So then I have my equation of y equals 42x plus 75, or we could plug in the variables we were provided, t equals 42 times m plus 75. Number 6, we have another word problem. So for this one, we're writing an equation to model the relationship between h, the number of hours, so that's changing, and c, the total cost, our dependent variable. Now we need to find what number is being multiplied by our variable h, and that's our slope. $250 is just how much it costs to bring your car into the garage, and then it's $175 for every hour. So our slope's $175, and that one-time fee is going to be our y-intercept of $250. We then create our equation, c equals 175 times h plus 250. Or we could put y equals 175x plus 250. For question 7, we're given another graph that just has some context to it, where we're looking at time versus total cost, and we're writing the equation that matches the graph. So we can start by finding our y-intercept, which is 40, because that is where our line crosses the y-axis, and then we see a perfect point right here. To get from our y-intercept to that perfect point, we go up 10 and we go right 1. That's why we have to look at these intervals. Even though this space is much greater, that still only represents one change. So our change in y over change in x is 10 over 1, or 10, which means our equation will be y equals 10 times x plus 40. For question 8, we're given a table and we're asked to create an equation in slope-intercept form to model the relationship. Here we're told that hours hiked is h and altitude is a, and we don't see the x and y, but we know that the left column in vertical tables is always x and the right column is always y because we read left to right. So now we're able to find our change in y over change in x to figure out our slope. To get from 490 to 508, we add 18. And to get from 0 to 2, we add 2. So when I take my change in y, which is 18, and I put that over change in x, which is 2, I get a slope of 9. To find our y-intercept, we look for what our y value is when x is 0, so that's 490. And our equation is then y equals 9 times x plus 490. For question 9, we have another graph where we're creating a slope-intercept form equation. We find our y-intercept pretty quickly because that is where our line crosses the y-axis, that's positive 160. And then we find another perfect point and we figure out our rise over run. To get from our y-intercept to this point on the right of our line, we have to go down 20, 40. So we're going down 40 and over 1. That means our rise is negative 40 over our run of 1, which means our slope is negative 40. So our equation would then be y equals negative 40 times x plus 160. Question 10 gives us 4 different representations, and we're trying to figure out which one does not fit because it doesn't show the same situation as the others. To do this, it helps to get them all into equation form. So when I look at answer choice A and I have this situation or word problem, we see that John already has $25 and continues to save $150 each day. So with this word problem, we're seeing y equals that 25 that he already had plus $1.50 each day. This situation matches with answer choice B exactly. Those are the same equation. So now we're looking to see if C or D doesn't match. To do this, we can check our table by either finding our rise over run. So let's go ahead and do that. To get from 28 to 29.50, we would add $1.50, and our slope here would be 150. We would have to work backwards to get our y value when x is 0. So to do that, I would have to do -2, which means I would need to do -3 on the y row, which gets us 25. So again, we see that equation of y equals 150 times x plus 25. So let's check D and see if it works. The y-intercept checks out. It's at 25. So now let's see if our slope is okay. I found this perfect point here, and to get there, we would go up 5, and we go to the right 5, 10, 15, 20. If I put my rise over run, that gets me a slope of 1/4, which would mean our equation is y equals 1/4 times x plus 25. This slope doesn't match everything else, so D would be our answer.